right, other than, there we go. All right, so common logarithm, base 10. All right, so when you see no base written, it's understood to be base 10. All right, that's the main thing you have to remember, and that this particular log is one of the few that are in your calculator. I'm tangled. There we go. All right, so base 10 logarithm, log base 10 of x is called the common logarithm. The log key, so if you look at your calculator and you see a key that says log, that is for base 10. There we go. And the log key on the calculator is used to obtain those common logarithms. So if you don't really need the calculator for log base 10 of 100 because 10 squared would give you 100. 10 to the second power gives you 100. The exponent you'd have to raise 10 to get 2/5 would be negative 0.3977940. It looks like a reciprocal, right? It's flipped. It's between 0 and 1. So we're kind of expect that we might have a negative exponent. Don't forget the parentheses. Log base 10 of 5 gives us 0.6989700, and what that means is that 10 to the 0.6989700 power would give us 5. And if you try to take a log of a negative number and you get an error message, that's because of any positive base raised to a power, any base raised to a power is going to give you a positive number, no negatives, right? So your calculator would be very upset with you if you take the log of a negative number. You're not going to get anything. Any questions on this? You get domain error. Oh, it's still error message. So this podcast is being done live for you, all you people who aren't here in class. The natural logarithm, right? So this is the other one that has a button in the calculator. So when we were using e to the x, we'd hit Shift ln. Well, ln is natural log. It's log natural is French. I can't seem to get everything in here. So ln x is the inverse of e to the x. Right? So logarithms base e are the natural logarithms. Abbreviation ln is generally used for natural logarithms. So instead of log base e to the x, we'll see ln x. Right? So we know that means natural. That means natural log. Right? So if we have natural log of 1, we get 0. As a matter of fact, if you have the log base anything of 1, you're going to get 0. And that's because e to the 0 is 1. And matter of fact, anything but 0 to the 0 power is 1. Right? So anytime this is just a 1 there, you're going to have 0 as an answer. Natural log of e is 1 because you'd have to raise e to the first power to get e. Right? As a matter of fact, those are natural log and e are inverses of one another, and we're going to learn that a little bit more about that in the next slide, or next 2 slides. So you can test out your calculator with natural log. You just won't hit Shift, you'll just hit the ln x button. Y equals ln x is equivalent to e to the y equals x. In other words, we're finding the exponent that we'd have to raise e to get certain value, to get some number. None of these can you do in your head. You have to use a calculator for natural log because you notice they're not very pretty numbers because our base is a never terminating decimal. It's an irrational number. With the exception of natural log of 1 you can do in your head because it's 0, and natural log of e you can do in your head because it's 1. Those are the only 2. So if we want to use our calculator to evaluate natural log 3, natural log negative 2, and natural log 100, natural log of 3 gives us 1.0986122. And since 3 is just a little bit larger than e, we would expect something that's just a teeny bit larger than 1. If you try to take natural log of a negative number, you get an error message because you can't raise a base to a power and get a negative number. Natural log of 100, you get 4.6051701, which would mean that e to the 4.6051701 power would give you 100. Any questions on just some real basics about the calculator and those 2 bases? So let's learn some properties. Right, so a base and a log in the same base cancel one another. It doesn't matter whether it's in exponential form or in logarithmic form. I put this in your notes for you. So, for instance, if we have log base b of b to the 7th power, the b and the b will cancel one another out and leave only the exponent. It's kind of like that one problem where the bases matched, and so the answer was the ratio of the exponents. In this case, it's kind of the same thing, right? So since those bases match, the answer is just going to be the ratio of the exponents. So that exponent and that exponent. So if that exponent is 7, the exponent on that b there is understood to be 1, and that gives us 7. Right? It also cancels if it's in the if that log is in the exponent as well. So if the base in the base of the log, regardless of where that log is located, match, the two cancel one another out. Okay? And if you have, so here's an example, all right? So we have log base 4 of 4 cubed. Basically it's saying, what exponent would you have to raise 4 to get 4 cubed? Right? Well, you'd have to raise it to the 3rd power, right? So these two cancel out, leaving only the exponent. And we'll learn another property to go along with that one. I don't think in the podcast, in the next podcast. I think it's going to be in class, but that'll make that even clearer for you. All right, so let's take a look at some, and there's some to write in your notes. All right, so properties of logarithms. All right, so this is a here is any base at all. Log base a of 1 equals 0. Since anything with 0, and the base can't be 0 anyway, anything to the 0 power is 1. Log base a of a is 1, since anything raised to the 1st power is just the same thing. All right, these are essentially identity, and they basically these two cancel each other out. So the log and the base and the same base cancel each other out. And that's true if it has an exponent, so it ends up being just kind of like the ratio of the exponents. So log base a of a to the x would just be x over 1 or just x. And the same will hold whether it is whether it's an exponent or you're just taking the log of that base. Right? So regardless of where the log is located, the base and the log in the same base cancel one another. It's the inverse property for logs. And then if your two logs, the bases match and they're equivalent, then what follows must be equivalent as well, which makes those equations really easy to solve because you can drop the logs and just set what follows equal to one another. And then, so natural log is just the same as any other log. It just has e as the base. So natural log of 1 is 0, since e to the 0 is 1. Natural log of e is 1, since e to the 1st power is e. Again, natural log and e will cancel, leaving only the exponent. And it doesn't matter whether the natural log, whether we're taking the natural log of e to the x or natural log's an exponent. E and natural log cancel, leave just the x. And then if you have the natural log of something equals the natural log of something else, the only way that's true is if those two somethings are equal to one another. So you can drop the natural logs if you were solving. Right? So we'll continue on with a few examples. All right, so here we have a few examples. All right, so we want to solve for x. Log base 6 of 6 equals x. Right? That would have to equal 1 because you're basically saying 6 to what power, and this is in your notes to fill in, is equal to 6.
Could we have all kinder through
and we're just going to keep on going.
bus bay for a bus evacuation drill? All kinder through 8th grade students to the bus bay for the
because there's not enough shoved into this day. All right, log base 3 of 3 to the 5th power, those two will cancel, leaving only the 5, right? So the bases match, it leaves just the exponents. 7 and log base 7 in the same base, they cancel one another out, it leaves just the x. And these properties will hold for natural log just like they hold for log. Right? So natural log and e cancel, leave just the exponent. E and natural log cancel, leaves the 20. Natural log of e is basically saying e to what power is e? Well, this would be 1. Right? So that's basically just 3 times 1, or 3. And then the square root of natural log of 1. Natural log of 1 is 0 because e to the 0 power is 1. Right? And then square root of 0, of course, is 0. Right? Everybody got these ones in their notes? And then we got a couple more that are in their notes, I think. 3 minutes. Okay, thanks. All right, so I didn't erase these from the other class, but I'll erase them now and I'll just go over them real quickly. I won't call on you, I'll just do the talking, I think. All right, so natural log and e, we'll do this together. Natural log and e would cancel. What's natural log of e to the 7x, class? 7x. How about e to the natural log 4x squared? What's that going to be? You're close. 4x squared. So e to the natural log of square root of x, what's that going to be? Just the square root of x, because the e and natural log cancel. So that's basically saying, because what's understood, our base is 10. 10 to what power is 1,000? What would that be? Yep, 3. Log 10 to the 7.1 power is going to be 7.1 because that base here is 10, so those two cancel each other out. 10 to the log e power, e would just be e because 10 and log cancel each other out. They're inverses. What is log base 4 of 4? 1, right? Because 4 to the first power is 4, and of course 5 to the first power is just 5. So you can see that here these two, this log expression here is just 1, so you're basically just saying 5 to the first power. And then let's rewrite this so that we can solve that. So we have log base 2. 8 is 2 to what power? To the third power. Right? And then using power rules for exponents, when we have an exponent raised to a power, we just multiply. So we have log base 2 of 2 to the 3x. Right? And so then these two will cancel, the 2's cancel, and that's just going to leave the ratio of the exponents. So I'll write that separately, log base 2 of 2 to the 3x. These cancel one another out, and so it's just going to leave the exponents, which is going to be 3x over 1, or just 3x. Questions on these ones? Everyone get them in their notes. Okay. All right. Well, hope the class that's not here enjoyed this podcast. And in class on Monday, we'll do the whiteboard practice that goes with it. But watch the next podcast that's going to be showing up. Bye for now.